to hit mute. I think that's you. You got it? Got it. Yeah, so if you, don't use your mic, but if you say something, I'll repeat it so everybody can hear it. What's going on? We're having some technical difficulties with the projector. Yeah, it wasn't plugged in up there or charged, so. Okay. All right. Started here in a minute. All right, so today we're going to talk about cleaning data using SQL. Pretty important common stuff that you'll use. First, we'll do a little bit of a review of everything, and then we're going to move into cleaning data using wildcards, identifying, removing duplicates. We're going to do some string manipulation, numeric and date functions, and then there's some examples towards the end. We've got a good portion of students that aren't caught up with all the homework. So what I'm going to do is give you a take-home quiz for the next class. Those who are caught up, great. Everyone else, you'll have an opportunity to catch up on some of that. Okay, so all in all, for in regards to the homework, everybody did pretty well. There was one commonly missed question. So from the first homework, question number 7, what are the most common town names in America? Pretty much everybody used a count, and what came back is you would see like Austin a bunch of times, or like New York and stuff. The data is the records are by zip code, so there's another layer of details. So it was actually pulling duplicates. So the answer is to do a distinct count on the ID, and then that way you've narrowed down and kind of got rid of the duplication over zip codes. So far we've covered, so basic queries. And I want somebody to answer this here. So what are the two functions that you need to have in any SQL statement for the most basic query?
Would it be select from? So
Correct.
Select this from that?
Correct. Absolutely. Yeah. So if you think of when you do the select top 1000, I mean, if you put like an asterisk there, it's just going to pull everything. So you just really need the select and from. So extracting and storing data, we went over 2 ways to set up data tables or pull data into them. What were the 2 different ways that we did it?
Import wizard.
Yep. The other one?
Was it manually?
Yep. Yeah. Basically, like you're inserting values using SQL script. What if you're going to connect tables together? How would you do that? Like, let's say if a field from one table to another table is connected by, we had remember we had, so when we were trying to set them up and then delete some of the other tables, but it wasn't letting us because we had to delete something first, or we had to put the country table in first because something was created that the other tables were dependent on. Something unique. So yeah, so like a key, like primary keys or foreign keys. You don't always have to, you can connect anything from any field on the table, but if it's not unique, you'll get a bunch of duplicates and things like that. Especially when you get into like data visualization and you've got tables within that model. I mean, you can create just unique keys too, right? Doesn't have to be one of those. So joining and merging data. So when you're appending data, which direction are you connecting that when you're appending it? What's that? Yeah, sure. So the end of the data, so top, bottom. What is a requirement, the number one requirement to do that? Yeah, so Luke said you have to map to the same fields. Yeah, and you've got to have the same number of columns for both of those tables to be joined. Otherwise, you'll get an error. And then what is one of the more common or most common joins to use?
Left.
Left. Yeah. So when you're dealing with like a star schema, which is very common in databases where you've got one massive table and then little tables that can be joined onto that. Left statements is what I've used primarily, one of the more common ones. If you're exploring the data or you truly are trying to get a subset between the two tables, that's when you can bring in inner or some of the full joins. So class 4, I definitely find that it was one of the more difficult classes or challenging material that we went through. So far, the people that have turned in their homework did a really good job. So you are learning, which is good. Makes me happy. Subqueries, I mean, they have their time and their place. I would say it's, more for analysis when you're doing subqueries. Like you have a lot of data and you really want to sub-select it and narrow that data's focus. So today, SQL operators, case statements, logical functions, removing duplicate data, cleaning, formatting. So cleaning data, data wrangling is another name for it. I mean, you're really confirming that it's valid, that it's accurate, it's complete, consistent, and that it's uniform and usable. Common practice is let's say you get the raw data into a data lake or like a blob storage, and then you're going to create a different table that's cleaned and things like that. I wouldn't go in and manipulate the raw source data. I would move it somewhere else as you're going through it. A big portion of that is knowing the business knowledge to be able to validate, especially if you think about if you're going to pull, data out of a SaaS product, right? Different companies will use different parts of the software, and they'll vary by which the data entry process may vary across business units, right? Like, let's think of, we have, 50 different storefronts across the country. Very common. They're not all going to enter in the same data each time. And so it's really up to you to figure that out. Usually, like if there's null values, maybe you'll just leave them. In very rare instances, like if you absolutely have to do it, there are statistical methods to input values. So for example, I had a business unit that was recording a service basically on paper every month with account, and there was no transactions within the system, but it was like their core service, which was rare because that particular business unit specialized in this one service, and they did probably 5 times more than any other business unit. So it was their main source of revenue, right? So just from like accounting and tracking, like the revenue numbers were there, but not the actual service line details. So what we ended up doing is created we created a mean specific to their business unit for historical records that lined up pretty well with what they were doing. And then we fixed the data entry process. So moving forward, they were going to start doing that. Programming languages, the most typical one are going to be SQL, and in Python, I'm seeing, more and more business units or businesses that will use SQL as their primary tool, and then they'll supplement with Python because it's a more known language in the field of business intelligence. Not a lot of BI developers will use Python. They'll do mostly everything in SQL, or even no code environments. Like when you get into like the actual cloud compute, like the Azure Data Factory and things like that. Or what they'll do is because in Python, you can create data frames and you can run sections of code. It allows you to watch your data manipulations as you're working through cleaning that data set. And then sometimes they'll go back and just convert it to SQL if they know it's fully automated and they trust it and run it every time. And then make minor updates to the SQL script. Because in SQL, you've got to run the whole query, right? Like I can't test parts of it. I can't watch what's happening. So I've highlighted for Python libraries, Pandas is by far my favorite one to use. I think I mentioned this before. The creator of that Pandas library, which is the most popular library in Python, was asked, what is the most important thing to learn? And he said, learn SQL. That was funny. So survey, what's the least enjoyable part of data science? We all get attracted to AI, machine learning, predictive algorithms, and things like that. And then we all have this rude awakening where we think we're going to get in there and just work on that. Oh no, that's not what's happening. Almost 60% of my time is going to be, or they're saying 60% of it is cleaning and organizing data. Well, see here in another slide, like 80% of their time is spent roughly on, getting the data ready just to do the project. And then it's kind of funny when you're looking at all this code to clean up the data, which can be, hundreds, if not 1,000 lines long. And then you see the code snippet to do the machine learning, and it's like 5 lines. You know what I mean? I mean, there's a lot of, but sometimes you'll run it, and then even through the machine learning process go, oh, yes, something's not right with the data that you've got to go back and fix. And why there's typically more data cleansing when you get to that step is because everything has to be numbers, right? Like you can't have like names of states. Like you would need to have like 52 columns that are binary 1 and 0. So, what are the goals of cleaning it? Getting rid of unwanted observations. Let's say you're training a staff member to enter a service charge or something, and it's a test record, and they just didn't delete it and they left it in the system. So if you kept that in there, right, like you could be overstating whatever the revenue was or number of customers, very key metrics that everybody uses. So you have to come up with strategies to deal with those, but that would be a good example to get rid of them. I don't typically, if I find null values, I don't throw the baby out with the bathwater and just say, get rid of the observation. Maybe if it's just a field that data's, they're just not using it when they're entering data, I'll just nuke the whole column and it's just irrelevant. So structural errors. I think I've mentioned, like in the healthcare world, it's very common to see, 15 different signas for something, or they'll accidentally create another profile for a doctor. And now the team is half the time using one and half the time using the other. And so if we're going to clean that, we'll have maybe a table that is got the unique IDs for each of the doctors. And then it's going to allow us to aggregate everything by that particular physician. Or maybe we just want to go rewrite it, right? Like we know what's going on. We know it's the same doctor, but we're going to go through and uniform all those names. So then we can get actual numbers. And so you've got to come up with, like, I kind of call it like triangulating data, or you've got to come up with a truth source or a method. So for example, maybe from whatever software system that you're pulling data from, you can run a report. And let's say we want to see what the revenue was, and I'll go back, 3 months. Actually, I'll go back 3 years on a full project, but let's say I want to check, the 12 months. I'll have the system generate a report. The first thing I'm going to do is I'm going to try to match to those numbers. As you go through this process of cleaning the data and manipulating it, you may find that what's coming out of the system report is incorrect. And so then you've got to figure out why it's incorrect. And then you're creating another data set, right? And so it's why I kind of call it triangulating, is because you want, you're going to take two different sources, maybe create a different one. Demographic data. You're like, if you took 3 different sources from something and then you compared the data, you're lucky to get 50% of those accurate or to match each other. So for example, when I was working with, trying to find all the doctors across the country to create market analytics, if you took WebMD and then you took health grades, and then if you took maybe like an official directory, like the American Dental Association, and you compared all 3 of those, you'd be lucky to get a 50% match between any of them. So anytime you work with demographic data, there's a certain level of inaccuracy you're going to find. Like when I was pulling dentists, like I'd find chiropractors that also labeled themselves as a dental practice. Why? I've no clue what the point of that is. Maybe they were doing like some jaw release or something, and they thought that's a good marketing tool to get out there. I don't know. But that's where it's important to communicate directionally right versus precise, which is one of the most difficult things to do, is when you're trying to communicate to a C-suite executive the concept of that. Like usually they're like, oh, this isn't that right. And it's like, well, no, this is as right as we're going to get. And it's better than nothing, right? And it's still decent. Okay, so typically used with a like operator, SQL wildcards. They're characters that you can use when comparing or substituting one or more characters in a string. So for example, the percentage symbol, BL percentage finds BL, black, blue, blob, anything that includes some BL in there. We've got the underscore. So we're going to keep the H, keep the T, and that'll give us back hot, hat, or hit in that 3-letter string. So then if we used multiple characters in brackets, so an O and an A in there, it'll find hot, it'll find hat, but there's no I, so it's not going to find hit. Characters not in the bracket. So you're saying, you know, I want H and T, but I don't want anything where there's a O or an A in between. So that one's going to find hit, but it's not going to find hot or hat. And then you've got the dash for a range of characters. So you've got basic like C, something in between, and a T. That'll find cat, and that'll find CBT. But it's not going to pull anything if there was like, you know, if you change it to A to Z, it'll find other stuff, right?
Are you able to mix and match these together in like the same word or even the same prompt? Or like, are the things in brackets you can really only do one at a time?
Yeah, that's a good question. So you would have to put another like in there,
Okay.
like operator. So here's an example, and I'll send over all the SQL scripts from this in case you ever want to use them in the future or you need examples. Okay, so let's find countries that contain the string AIN from our country table. So we've got name because that's the field in the country table that contains all the country names. So we're just going to rename it as country. And then where we've got AIN within the name. So you've got Bahrain, Spain, St. Kitts, St. Lucia, St. Helena, St. Pierre, Ukraine, so on. For our next example, cities starting with any character that is followed by Undin, making that one obvious, which would be London. All countries starting with a Z or a K. So here you've got, you know, we are using 2 in there. I thought, sorry, Patrick, I thought what you were asking is like making multiple statements, like separate ones.
Well, I mean, that third example answers most of the question.
Yeah, okay, that's what I thought. Yeah, all right.
For
I
the
just
one,
didn't understand
for the
your
ones
question.
in brackets, can you put like multiple brackets in there? So like if you wanted it to start with Z or K and end in A or Y, could you do a bracket after the percentage and do bracket AY?
You know, I've never done anything like that. Where I've done things is like doing where and, doing like an and statement and then doing another condition. We could try it. I don't know.
Just curious.
Yeah, well, we'll mess around. Type it into ChatGPT and see what it comes out with. Okay, removing duplicates. Typically, raw data is not going to have a lot of duplication because it's transactional if it's like unsummarized data. There are some nifty ways where if you did want to check, just to double check, it's always good to do, is instead of just identifying like a value from a column or even creating like a unique ID that you think is going to avoid duplication. And I typically have done this in Pandas, and I got a little slide at the end of this today, is it'll actually check the entire observation and then compare if there's duplicate values. I do it as a sanity check every time because, I mean, if you're working with millions of rows of data, I mean, it's just not good to trust that. It's always a good test. Where you will deal with it more commonly is with your joins. And so, typically when we do a join, and if we're doing like a left join or something, it'll, and we don't have a unique value that we've joined that on, you'll get a lot of duplicates. So it's always good to test that every time. So typically that's my first test after I do a join, and then I'll actually understand more about the data. What I thought was unique wasn't unique. And so now I've got to go update the accuracy, check validity of that data. And then let's say I'm doing a bunch of data transformations at the very end as another sanity check. I'll deal with those duplicates. That is by far, I think, one of the biggest accuracy mistakes that I come across is when you're joining tables and producing duplication, especially when you've got like you're doing numerical counts, revenue, sales, cash coming in, customers, things like that. It'll throw off your numbers in like a nonsensical way. And then that's where we go back to, we've got to have a truth source, right? And make sure those numbers are correct. I mean, one time I was working with a consultant, heck of a Python programmer, whiz, learned a lot from him, but couldn't get the concept of needing to pull a report to validate numbers. He was just using the file size. Well, no, it's the same file size as this other one. That should be right. And I'm like, no, and we would open them up. I'd check the report and I'm like, no, you're $2 million off in 1 month. It's not right. So, 3 key methods. You can select distinct records. You can find them by doing joins and find them duplicates via aggregation. So actually, that was question 1 or homework 1, question 7. That was the most common incorrect, question or missed question that we had. Is we didn't check for duplication, and we did counts where big cities had a lot of zip codes. And so naturally, those are going to populate. And then we used a distinct to get rid of those and find them. Find the truly distinct counts there. So find U.S. cities with the same name. And we're just doing counts that's greater than 1. And so Arlington, Aurora, Columbus, Glendale, Kansas City, Pasadena. But as we'll see, when we're identifying duplicates by the key, it's actually not true, right? Because there's an Arlington, Texas, and there's an Arlington, Virginia. And so if we want a truly unique list, we're going to use that distinct operator. And so before we had 2 Arlingtons, 2 Auroras, so on. Afterwards, we're just going to get a list of 1. So if you wanted, and if you didn't want to do that, right? Like we use that previous example because we know that they're not really duplicates. So if we took all of the data and we said, identify duplicate values over across each observation, it's not going to get rid of anything, right? Because they're different states. So here's some scalar functions that are most commonly used. You know how to read, so it's just a reference for you later. I don't need to read them off for you. You can see it. So numeric and comparison functions. We've got format. And what that's doing in this example is when you're saying 3, you're setting the decimal places to 3. That's actually pretty common. If you're pulling data where maybe a column was calculated within the database, like let's say, I don't know, like revenue or something like that. You'll see like, let's say like 2 million in the decimal place, and there'll be like 8 decimals after that. And so that's a pretty common occurrence where you're going to want to say 2 decimals, right? Let's see. So if null, you're just saying if the value is null, let's set it to 500. If it's not null, then it's just going to skip it. If you did an is null, so this would be, this is a pretty good one to use, is you would create a new column and then you could flag it. Like, is this a, you know, was that field null or not null? So coalescing, we're going to return the first non-null value in a list. Okay, so we've got, here's some numeric function. So converting a decimal to an integer, we went over that like when we were doing the import wizard, right? So it's always good practice that when you're identifying a full list of columns that you put the specified data type in there. You know, when you learn pandas in Python, pandas will try to identify to the best of its ability what the data type is. Doesn't always get it right. So it's always good to specify that right away. Another issue that can occur is the process of, let's say in Python, trying to identify that data type is computationally expensive. And so that process can really slow things down, or if it's too much, can actually crash your program. It'll stop working. And so you can avoid that whole thing just by identifying right away when you're pulling in the file.
Does that have anything to do with why there's like multiple versions of the same thing? Why you can set like an integer 3, integer 5, integer 7, or integer max? Is it just the data size?
Yeah. Well, so if we get, a lot of it is going to be like memory usage to perform the function, and like saving space as well. Because keep in mind, we're using simple data sets, but you know, eventually you get to something that's got, you know, 5 million, 10 million different records, and now you've got to be mindful of those things. So if you set integer max to everything, like that can become expensive. That answer your question?
Yeah.
Yeah. I guess too, like if for some reason, maybe with like, you don't expect to have a certain amount of, let's say, integers, like, you know, 100, 1,000, a million, whatever. You could set a limit, and then if an error is produced, that could trigger you to go review what happened in the data. I'll give you a use case that I saw once. There was a service line of implants, like putting an implant into somebody's mouth, and let's say it was $2,000 was the typical charge for it, but somebody fat thumbed it, always on a Friday. It seemed like, hey, how's it going? Sorry about that. And somebody always decided it was going to be a platinum implant. They type in $2 million into that service line, right? So maybe one way that you could put that in there is if you put integer 4 or 5 or something like that, and not 7, and then your system would cause an error, and then you could log the error, and then you could automate getting an email to go review that, right? That's one way that you can always keep an eye on a system that's automated. Then the second one here is we're coalescing the null values and then putting a 0 in there. Which you wouldn't want to put a word, right? Like if null value, like make it missing. Well, if we did that and then we tried to calculate something, you're going to throw up an error because you can't combine string with integers. It's not going to perform a calculation function. Also, too, when you're joining, like even if, like let's say like some of them were saved as a string, like even though it was a number, and then others were, you like appended more data and then now it thinks it's an integer. And then later on, you're trying to join a table onto that, like you're not going to be able to do it because it's two different data types. So here's some different formatting functions. Concatenating is very common. That's one of the more common ones that I've used, especially like I'm creating a unique ID to aggregate something on. So maybe I want to create a key between Arlington and Virginia, or Arlington or whatever the state and that city name is, and that's now a unique ID that maybe I want to aggregate population on, but I'm not crossing over across state lines. So character indexing, that's returning the position of the first occurrence in the substring. Not something I would use a lot, but maybe you'll find a time where that's useful. Trimming. So that would be like either like before or after prefixes, suffixes. You're going to like do a replace, or you want to get rid of something. That's pretty common to use. And so is replace. So all the occurrences of a substring within a string, you're going to replace it with something. So here where there's like UR, we're going to say we just want R. And so it would change like W3 resources, basically getting rid of the U. If you want to change something to lowercase or uppercase, also pretty common. Like it's good to keep things consistent. So if you were dealing with like, especially data entry stuff, right? Like some things are lowercase, some are upper, some are a mixture of both. And then if you're going to want to try to find values, that would be a pain in the ass, right? To like, why isn't this working? Well, that's because I didn't type it in correctly. So I'm just going to make everything uppercase. Length returns the length of a given string. We'll go back to setting the varchar, right? Like we want to see whatever the length or maybe a max length of something, and then we could change it there or set that to 8. Then we got substring, extracts some characters from a string. So right there is 1 through 3 from SQL tutorial. And so it's going to return SQL. Okay. So here's an example of we're going to concatenate the city and the state full name. We're creating abbreviations. Formatting date functions. This is a pretty common one. Oftentimes, dates mostly have a timestamp. If the timestamp's not used, it'll still say like, zero, like that hour, minute, second. It'll just be like 000000. And that's not, well, it's an eyesore. It's long. And if we're not using it, just get rid of it. So you can format the date. Pretty typically, it's going to be your 4 numbers for year, 2 numbers for month, and 2 numbers for day. Sometimes you do want to keep the timestamp. For example, I'm building a healthcare SaaS product that the whole point of this thing is try to reduce the length of stay that somebody's in the emergency room. And so I want to see when that patient checked in, when they initiated a consult with an on-call specialist, and then how long it took for that specialist to make a disposition. So when they came back to the ER doctor and said either, send them home, I'll be there in an hour, or schedule something for tomorrow with my office. Right. And so that's when you get to like date diff, is you can see the difference between 2 things. So, or another example would be, how long did it take to fulfill an order? Like somebody called, they ordered a part or a computer or something like that. Then how long did it take us to get that out the door? And then maybe I'm going, oh man, like, why is this going up and up and up every month? That's not good. And now you've got a metric to try to monitor and to decrease that amount of time. Weekdays, week numbers, 1 for Sunday, 2 for Monday. A reason to do that is if you were trying to visualize days of the week, it's not going to work, right? Like if you want to see them in the correct order, like Monday, Tuesday, Wednesday, Thursday, Friday, whatever, you can make that field 1, 2, 3, 4, whatever, and then you could sort in that visualization to get things in order. Same goes with months, right? Alphabetical order doesn't work. And so we've got to set some mechanism to get them to visualize in the order we want to see it. You can return days, you can return month, you can return years. And then on top of that, very common usage of that. So as you're extracting the month in one column, you're extracting the year in another column, and then you concatenate those together, year and month. So you can look at things in order with one column that's, ascending or descending. So we're getting the number of years since each country's independence. And, as I mentioned before, like, so for example, we've got null values in here. We're just setting those to 0 where there's a null, but the ones that actually have a year of independence, we can see 105, we can see 49 for Angola, and we're going to get zeros for the other ones. But let's say you were going to calculate an average and you left those zeros in there. Not good, right? And so you would want to treat those in one way or another. One way to do it is, and here's a case where you maybe want to remove those, not necessarily from the data, but maybe create another view and then get rid of all the rows that have a null value or that have 0, and then calculate your average. That's actually a very common mistake that I see quite a bit. Is, a lot of analysts will just do it without looking at the data. Another thing that I see is pretty common is, let's say a business unit, they were not tracking something in, let's say, 2023, and then they changed their data entry process to track something in 2024. And we're doing some average or year-over-year comparisons and things like that. And so their 2024 numbers look like they're improving significantly, or from whatever the last period was, because maybe they just started doing it or didn't have anything there. And it can be very misleading. People are celebrating, oh my God, these guys are doing great, right? Like they're improving the amount of new customers that they're getting. Well, it's like, no, not really. Because the first 6 months of 23, they weren't tracking it. And now it's this, they did the last half and now it's showing improvement. So common SQL syntax errors. If we were watching Marcus last time when he was sharing his screen, it was little stuff. Small things, incorrect table name, column name, value, like the way we have world.country. Did you capitalize the C? Single quotes versus double quotes versus backticks. Integer versus varchar, that bug bit us quite a bit in the import wizard, or small integer versus big integer versus regular integer, joining on the wrong column, which is what we have on the right, over filtering on the where clause. Maybe I removed something I didn't intend to, and then maybe after I'm trying to create another view and join something else, and now it's not joining appropriately. And then within that where clause, maybe I'm not formatting the date properly. That's pretty common. So if I'm trying to where between January 1st, 2022 and July 1st of 2023, because you've got the 4-digit year, but where it can get confusing is that month and then the day, right? So if I did 01-01, yeah, that is technically right for January. But then if you forget which order that's in, and I start typing in July, I accidentally put the day as 01. Well, and then the month at where day should be. So, it would go 01-07. You know what I mean? Like, so it'll technically pull those and you're not going to notice it. It'll still run, but that's actually incorrect, right? Where it'll flip an error, obviously, is once you get, 13, 14, 20s or whatever, it's not going to work. I go, why? Okay. So we've done a bit deeper into cleaning data using SQL. There's some advantages and there's some disadvantages of doing it in SQL versus Python, for example. Can somebody give me an example of a disadvantage of doing this in SQL versus an advantage of doing it in Python?
Well, Python will be pulled from the.
So Luke said maybe Python's pulling from SQL data and maybe not altering it. So, I briefly mentioned it, and you've got to run the whole query for SQL, right? In Python, you can test each of your manipulations individually. So, for example, I got criticized for doing that once by an engineer, and that's how I was taught in graduate school. And the whole reason behind that is because when you're going through the data exploration process, you want to see each of the steps and the things that you're doing. So you're kind of scripting, okay, well, this time I'm going to take these 3 different names and I'm going to, create a new column and make those, all the same. So, like the 3 different doctor example I told you about. And as you do this, you don't want to get rid of the column. You want to always try new stuff. And then, okay, now I want to deal with my duplicates. So I have the ability to create a new data frame. It's almost like you're creating a new table each time, but you're watching your manipulations and you can go back if you've got to change everything. At the end of it, when you're like, I got this, is solid, this is accurate, I'm confident in what we've done. If you're doing it in Python, you can consolidate all those steps into one, function. You're just not going to be able to see what happened, right? It's just going to go and do it and then produce the output. In SQL, you don't have that luxury, right? You're going to have to do a different like query for each thing that you're doing if you want to monitor that. So that's one reason, a good reason to do it. But I've also seen engineers, like once they figure it out in Python, they just convert it into a SQL query, and over time, as you learn to program, you start to realize like different languages are not that different. They're like sisters, not identical, maybe not even twins, but extremely common. They look alike in some ways, you know what I mean? So I would always explain that, like, R and, Python, for example. R, has anyone heard of R? Yeah, so it's, if like we were doing I did a clinical research paper, and I did a test with our data scientist where I was like, you run your models in R, I'll run them in Python, and let's see if we get different results. Sure enough, we did. And then we dove into it to figure out why we got different results. And I can't remember the exact details. It was some logistic regression stuff we were running. But we were actually more confident with R. And so there's reasons to do that, right? But why Python is typically more common is because you can actually do SQL within a Python program. And then if you're trying to automate something, Python is fantastic, right? Like I can tell Python to go, here's these, somebody from finance just gave me 10 different files of, revenue and cash collections and accounting transactions and banking transactions. And, let's say with banking transactions, and they gave me one for each month. And it's not in a database, but they want us to create a database, right? And these files are on my computer. I've really only got to do this once, because after that, like, we'll create something to automate loading that. You can go identify the folder, and Python will grab each one of those files and do that merge, that we learned by doing it in SQL. Maybe in a blob storage, you want to combine different files and stuff like that. Maybe you also, you're on an on-premise server and it's old and, really, you can't really do much with it. Like, for example, a cloud-based software program that only has the ability to manually go in, select this report, spit out all the transactions, right? I've actually seen that, and they wouldn't allow you to have read-only access to the database. They're like, they'll give you basically like an import wizard, like an extract wizard. And so, you can create a Python program that'll actually go double click, open it up, go select through the menu of options, export it into a folder, right? And then it'll copy all those files over to an SFTP server. Old, I know, but that's what we had to deal with at the time. And now I can go pick that stuff up, right, from an SFTP server and then load it, through like Azure Blob Storage, and then connect it to the database that way. Or pull it into a virtual machine and run some stuff over there. So you can embed SQL within a Python program. You can do other stuff with it. You could also, if there's errors that are generated, you can use it to create and log any of those errors and then email you a message of whatever those errors are. So that's a common thing we did because, none of us, one of the requirements is, for one of our projects we did is we had to update the data every night at like 8 o'clock at night. And I'm like, who wants to do that? You know what I mean? And so rather than getting in and, I better go make sure all this stuff ran properly. Sorry, Luke and Patrick, I didn't notice you were Did you guys drop off and come back on?
My computer crashed. Found out it was connected to a light switch.
Okay. Moving. So I was just saying, like, we're talking about some advantages versus disadvantages of doing some cleansing in Python versus SQL. And I was saying, you know, doing it in Python, you can actually embed the SQL script in there. You can also do a lot more things in Python. And a project, you know, 8 o'clock at night, we had to do data refreshes, you know, and we had a mixed bag of different systems, different, you know, virtual machines. I mean, some of them were a laptop in an IT closet to run stuff, whatever we had to do to get the job done. And so if you can imagine at 8 o'clock at night, going in and trying to make sure everything ran is, you know, a 2 to 3 hour task. And so what we did is we logged alerts across all the different systems, and then an email would go out to the team. And then we also had people designated to address it, but it would say exactly where that error was. So you could do all this in one program, right? SQL is not going to do that stuff. You know, you can't use SQL to go log into a virtual machine or a laptop in an IT closet where you can with Python. So good intro. Additional resources, cleaning data with Python. There is a Python class. Is anyone doing that? I think it's in November. Cool.
I'm doing it. It's part of the business intelligence course, which I think a lot of us are in.
Sweet. Yeah, I think you, and even with this stuff, you still need to have that knowledge of SQL. I mean, like I said, you can connect to SQL databases directly within Python and pull that data in and create data frames. So instead of doing SQL view, SQL this, SQL that in a different query, you can do it all right there. So I think all of you will like it and get a kick out of it. I was hoping I could teach it, but I got two like long-term fractional like CDO contracts, like 6-month things that I got to do that I'm going to do at the same time, which I'm not sure how that's going to go, but but you know, so I won't have the time for it, but I'm sure whoever they have to come teach it will be pretty awesome. So Pandas library is your best friend. There's other libraries that you can use, like NumPy, you know, that's for like manipulating numbers and things. Very simple syntax, like drop duplicates, and you don't have to identify a column. Like if you just leave it blank, it's going to look at every column in the data set, basically squeeze it all together and say, is there a you know, get rid of those if there are any duplicates. Renaming columns is very easy. Skipping over unnecessary rows in a file. So surprisingly common. Like let's say you are getting banking transactions and whatever the output is, or I've even seen this in other SaaS systems, like before the actual columns and observations starts, it'll give you information about like who exported it, the time of day it was exported, what report was used to export it. And like, let's say it's the top 5 rows that's consistent, and you don't need that stuff, right? So while you're importing it, you can tell it to skip the first 5 rows, and then you're getting the actual column and observations in. So yeah, and then I also mentioned too, like you identify all the column names, you know, as things are coming in, and then you're going to specify the data types. Yeah, I just, when you get into exploring the data, and then, you know, some of these other methods that are not your basic, there's a database there, like web scraping, for example, you're going to produce like, you can connect directly to systems, provide like the login, the user name of whatever it is. You can use Python to write to .cfc files. Like when I took down the WebMD website. Like I was producing a file for each state. And then that data is now ready for you to pull into a SQL database. So there's a ton of use cases for it. Okay, so for today, I'm ending the lecture. So I got to get in the habit of doing this and ending the stream instead of rambling when we have questions. So I'm ending the stream now.